Okay, let me add um, maybe some personal tips for formatting scatter plots. And this isn't really just for formatting scatter plots. This is kind of formatting just about any graph that you're going to do in software. I have here that this is for maybe Microsoft Excel, but this would also apply to Google Sheets. So what you want to do is you want to have a graph, and the main purpose of the graph is to communicate information. So you want to be able to communicate visual information as clearly as possible. And so in order for it to be clear, it needs to be readable, and it needs to be readable in different sizes, and it can't be overly cluttered. So you have to find that balance between uh, putting as much information as you can without it being too much, and having everything so that it's readable, okay, at the same time. So these are some constraints that I put on graphs myself, and it seems to serve me well in a majority of my graphing situations, okay, no matter what I do. And this has been from a process of trial and error um, over a period of years. So, first of all, I won't have a chart title because you don't need one, because you're probably going to end up having what's called a figure caption. Oh my goodness, what's going on here? So, you're going to have a figure caption instead, where you put like figure A, blah, 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 and you explain it. Okay, so you won't need a chart title. Um, so you'll typically want to have a border around your data. And having a 2-point thickness border seems to work pretty well. You want to set up your border so that there are no data points that touch it. So you can see that there's, space between the edges of the graph border and the actual data points here in the middle. Um, so on the topic of not having data points coming in contact with the border, you also don't want your data points to come in contact with the tick marks. So I usually format my tick marks to always be on the outside only, okay, only on the outside and not on the inside, okay? So usually setting up tick marks to be on the outside is an option that you can customize. What else? So it's also good to maybe have the data points to kind of settle on a point size. Depending on the shape you're using, you can use circles, you can use squares, you can use triangles. A point size of 7 to 12 seems to work pretty good for scatter plots. And typically within a graph, you want to make a graph in black and white only. And why do you want to put things in black and white? So you'll notice here, I kind of did something kind of bad in that I formatted this line of regression equation and the line of regression itself in the color red. Now, often when things get printed or reproduced, they're not reproduced in color, they're reproduced in black and white. And depending on the software that's doing the conversion from color to black and white, red like this could end up being like a really light gray, so light that you can't see it. So what I should have done is instead of making this a red dashed line, I could have just made it a black dashed line. And the fact that this line is dashed, it looks significantly different from the data points, and it'd be easy to see. So what I should have done is I should have made, this line, I should have made it black instead of red. And likewise, this text that I put in here, that too should have been black. All right. Um, so what else? Okay, so these sizes here that I'm talking about, that's also relevant to the size of the graph that you're making, right? So I typically format my graphs to be 4 inches high and 6 inches wide. What's the reason for that? Well, if I want a graph to fill the entire width of maybe of an 8.5 by 11 piece of paper, a 4 by 6 is usually pretty good, it being 6 inches wide. Because when you're using an 8.5 inch piece of paper, you have an inch from the left and an inch from the right. Now you're down to 6.5 inches. So, having one that's 6 seems to fit pretty comfortably if you were just going to have one single graph across the entire width of your page. Um, Now, so that's a reason for having it 4 by 6. Now, you might want to put two of these side by side. And so if you're going to print these two side by side, then you're going to be reducing it down from 6 inches down to 3 inches. Okay. But if you make it at 4 by 6 and you make it with these dimensions, then when you shrink it, it'll still be readable. So make all your graphs to this 4 by 6 dimension. All right, so if you make this graph to be 4 inches by 6 inches, um, then you could put the horizontal axis label as 18 bold, sorry. Um, and don't forget to put the name of the random variable and include your units in parentheses. So when I say time to completion, you'll know that these numbers down here are represented in minutes. Okay, and if this axis is 18 bold, then the vertical axis will also be 18 bold. Now the axis labels, for these tick marks, again, you want those to be bold and just make them a little bit smaller. So if the axis title itself was 18 point, make the axis labels a little smaller at 16 point. It helps the axis titles to stand out a little bit more. Okay, so if you make your graphs with these kinds of dimensions, with these kinds of font sizes and bold, then if you take this 4 inch by 6 inch and you save it as a JPEG or a PNG file, right? So save it as a JPEG or a PNG file at this dimension. If then you need to shrink it down later, you'll be able to shrink it down, no problem, and it'll still be legible. Okay. Oh yeah, and something else. So you want to try and keep, the chart area. You want to keep this chart area here in the middle as clean and as possible. So you generally want to avoid grid lines if possible, because you get too many lines in there and it makes it more difficult to read. So only unless a grid line is absolutely necessary, do you want to put them in there. Otherwise, you want to try and avoid putting them in there at all costs. I mean, and it's like, okay, so how do I know what I'm talking about? Well, look at these graphs that I did a little bit earlier. All right, I created these graphs using these dimensions. I made them at 4 inches by 6 inches. And look, I even reduced them by a third, down to a third, like 33% of the original size. And it's still legible, right? It's still easy and clear to read. And I was able to fit three across. That's more of an extreme. You won't have to really go smaller than that. But even at this size, it's still legible. And that's because I formatted them with these uh, with these parameters here. Okay. And like I said, avoid using color because when color is printed to black and white, the color information is lost. So, here was a graph that I made. Um, I was still learning to make good graphs. One thing I could have done without is I could have done without the grid lines. You see the grid lines in here. They really don't help very much. So I should have done without those. Now, what a lot of you would be tempted to do is you'd be tempted to make this line a color like red, this line orange, this line green, this line blue, and maybe this line purple. Have different colored lines. But then the problem is that when you go to print this or someone else is looking at it and they're looking at it in black and white, all they've got are shades of gray. And this legend won't help you because that'll be in shades of gray, and the shades of gray will be too close together for you to even read this graph clearly. So instead, keep it all in black and white. And when it's in black and white, you can differentiate between different data just by changing the data point symbols. So use squares or circles or triangles or diamonds or pentagons. Okay. And you can connect them with lines. You could do dotted lines, dashed lines. You could do dash, dot, dash lines. There's a lot of different black and white options you can use to help differentiate between different uh, patterns of data on a graph. So here I was graphing the results, the magnetic results of 5 different samples I made. And you can clearly follow the behavior of one sample amongst all the others just by looking at the difference in the symbol shape for each data point. It's very easy to follow. I have my axis title here, my axis title there. I should have made this a little bit bigger and made it bold, made that bold. I should have made this numbering here bold as well and taken the grid off. Um, so again, scatter plots are meant to show patterns, okay? Um, and you want to be able to communicate, those patterns as clearly as possible. Now, the reason why you don't want to have a graph title at the top is because, each graph that you make will have a caption underneath it. So the caption describes the picture, the graph itself. And you don't have to do anything special, just 1 or 2 sentences that describe the graph. That's it. So what is this that we're looking at? It's a scatter plot. Okay, a scatter plot of what? The hysteresis temperature versus magnetic exchange bias. So what's on the x-axis versus what's on the y-axis. And then for what? For 8 nanometer iron oxide powder samples processed at 550, 650, 700, 800, and 900 degrees Celsius. And that's represented here, 8 nanometer powder at these temperatures, processed at those temperatures. And then I put, in parentheses and italicized, lines connecting data points are visual guides for the eye. Okay. The reason why I did that is typically you don't you don't want to draw lines between your data points like this. Okay, you typically do not want to do that because when you draw a line between this point and this point, what you're communicating with your graph is that all the other points between those two are going to be on this line, and they're not. The other ones could have been up here and done something like that and not followed this straight line between this point and this point at all. So typically you don't want to connect your scatter plot points with lines. The only time that you can get away doing it is if you're trying to show that there is a potential pattern here. And I say potential, a potential pattern. But then if you're trying to show that there's a potential pattern, then you need to put a disclaimer. Lines connecting the data points are visual guides for the eye. It's to help you see a pattern. But you need to put that disclaimer in there. Okay, and I'm just telling you this so that you can have, some journalistic integrity, some scientific integrity, some engineering integrity, some healthcare professional integrity, in your work. All right. Here I talk about figure captions. What is a figure caption? A caption is a sentence written directly underneath a figure or a table with two reasons for being there. The first reason is so that you can reference the figure later. So later on, you can say in figure one, blah, 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 blah. And the second reason is a sentence describing what the figure is about, what kind of figure it is. It's a scatter plot, what variables are being related, this versus that. And if multiple data sets are present, what are they? And that's it. No more, no less. Okay. So that kind of concludes um, the formatting of making graphs in general, but scatter plots a little more specifically, and kind of what my design philosophy is around that. Again, I've published papers, in peer-reviewed journals. I've made, graphs for posters at national and international conferences, and these look really good and sharp. Um, and so this is what I would recommend that you do. Okay. Thank you very much. Let me know if you have any questions.